Jai Hind. My name is Nidhi Singh. I am assistant professor in electrical and electronics engineering department from Ajay Kumar Garg Engineering College. Today I am going to discuss topic that is Thevenin's and Norton's theorem, which is from subject basic electrical engineering, and this is a topic from unit 1. And in this I am going to also discuss the numericals which are being asked in university examinations. So we'll start the lecture. So first we will see what is Thevenin's theorem. So basically the Thevenin's theorem, it states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of voltage source VTH in series with resistor RTH. So if there is any circuit which is a linear, or we can say it is a bilateral, we can replace any circuit by using this Thevenin theorem, in which we can convert the circuit in equivalent circuit in which there will be a single voltage source. We call it as a Thevenin voltage, and there will be a resistance in series with it, that is called the Thevenin resistance. So here we can see VTH is the open circuit voltage at terminal and RTH is the input or equivalent resistance at terminals when the independent sources are turned off. So here we can see that this circuit is replaced by the Thevenin equivalent. So here we can see there is a VTH and RTH, and then the load, we can connect this load here, right? So we have converted this circuit in the Thevenin equivalent circuit. Now how to find this Thevenin voltage? Now the next question is how to find the Thevenin voltage. So to find the Thevenin voltage, suppose here this is a circuit and we have for finding the Thevenin voltage, we will remove the load in which you have to find the current or voltage, that will be considered as a load. So you will remove that load. Now this terminal is open, you will mark this terminal. So here we have marked this terminal as A and B. So practically if you place a voltmeter here, right, if you place a voltmeter here, you can measure the voltage, and this voltage is nothing but this is the Thevenin voltage, or we also call it as a open circuit voltage. So this VOC and VTH, they both are same things. And if you are finding it out theoretically, so you can apply the node analysis, you can apply the mesh analysis to find the voltage across this terminal. Now next, how to find Thevenin resistance. So as we have seen, to make a Thevenin equivalent circuit, first we have to find the Thevenin voltage, and then next we have to find the Thevenin resistance. So how to find the Thevenin resistance? So to find the Thevenin resistance, we have to deactivate all the sources of the network. So source could be a voltage source could be a current source. So how to deactivate the voltage source? So to deactivate the voltage source, what you will do? You will remove the source and replace it with a short circuit. So if there is a voltage source, you will replace it and you will short circuit it. And to deactivate the current source, you will remove the source from there. And after doing, you will see the equivalent resistance from the terminal from where you have removed the load. So the equivalent resistance is equal to the Thevenin resistance. So here this is a simplified circuit. So we have converted this complicated linear circuit in a simple Thevenin equivalent circuit in which we have one single voltage source which we call the Thevenin voltage, and we have a single resistance which we call the Thevenin resistance. So now after converting this circuit into Thevenin equivalent circuit, now we can place a load here, and if you want to find the current or voltage, you can find it. So now you can see that this is a simple circuit. So by applying the loop, you can, by writing the loop equation, you can write IL is equal to VTH by RTH plus RL. So this is RTH and this is RL. So RTH we have already found, RL value will be given, VTH also you have found. So you can find the value of IL. Now what are the main steps to find Thevenin equivalent? We have seen what is the Thevenin theorem, we have seen the statement, and now we know that we can convert any circuit into the Thevenin equivalent circuit. So if any numerical is given, so what are the different steps which you will follow? So the first step is you need to mark the terminal. You can mark it as A, B, X, Y, whatever you want. and remove the resistance, if any, in which current is to be obtained, right? Suppose there is one circuit, here the voltage source is here, and here this is a circuit. Suppose this is voltage V, this is resistance R1, this is resistance R2, this is R3, and this is RL. Why I am writing RL? Because here you have to find the current. The question is you have to find the current. So what you will do? First you will remove this resistance, right? You will remove this resistance and these terminals will be open. So you will mark this terminal as AB. So this is the first step. So you will remove this resistance. So So here, after removing this load resistance, the circuit will look like this. So if you have marked this terminal AB, so the voltage across this terminal is VTH, or you can see the open circuit voltage, that is VOC. So the next step is to find the open circuit voltage across terminal. So you will find the open circuit voltage, that is VTH or VOC, by using node analysis or by using the mesh analysis, whatever you can use. Then the step 3. So now you have find the VTH. Now you have the value of VTH. The next step you have to find the RTH. So how will you find the Thevenin's resistance between these two terminals? By looking into terminal when all the sources are replaced by their internal resistance. So all the sources. So in this circuit, if I am considering this circuit, the only source is the voltage source, right? So you will replace this source by its internal resistance. So suppose if it is an ideal case, so in ideal we know that the voltage in ideal voltage source, the internal resistance is 0. So if you will replace, so you will just remove this and you will short circuit it, right? So this will be short circuited, and from this here you will find the RTH. From this terminal you will find the RTH. So you can see this R1 and R2, they are in parallel combination, and this will be in series with R3. So this is how you can find the value of Thevenin resistance. So now up to this step 3, you have found the VTH and you have found the RTH. So the last step is to replace the network. Now you will replace this network with a equivalent Thevenin circuit. So what will be the equivalent Thevenin circuit? Here you will make one voltage source and one resistance here. So this will be the VTH and this will be RTH, right? And after this you can now combine here the load resistance RL. So now this circuit is in very simplified manner. So now here you can find the value of IL, that is the load current. So by looking at the circuit, now you know that this IL is equal to VTH upon RTH plus RL. So this is how you can find the value of load current, right? So here you have find the current in this resistance by using the Thevenin theorem, right? So if the question is given that you have to find the current in this branch, so you can use any method, like you can use the loop analysis also, you can use the node analysis also. But if in the question it is mentioned that you have to find the current by using Thevenin's theorem, then you have to follow these steps only, right? So here first we will take the first example. You have to find the current in resistor R using Thevenin's theorem. So resistor R is here. So now this will be considered as our load resistance, because the current is to be found in this resistance only. The value of this resistance is 3 ohm, right? So what will be our first step? The first step is to mark the terminals AB and remove the resistance, if any. Yes, there is a resistance which value is 3 ohm. So you will remove this resistance, the resistance is removed, and we have marked this terminal A and B. So this is our first step, right? Now what will be the second step? The second step, that you will find the VTH where at this terminal A and B, right? So the second step, find the open circuit voltage across the terminal. So if you look at this circuit and by applying the you can write the node equation at this particular node, that is C. So you can write it. Then if I write this, the voltage at this is VC, right? So you can write the equation 10 minus Vc by 5. Node equation we write in terms of current, right? So 10 minus Vc by 5, this will be the current in this branch, then minus Vc by 10, then this is a current source, we know the value of current which is coming to this node is 5. So this is the equation, this is equal to 0. We know that the sum of all the current at a particular node, the algebraic sum of all the current at particular node is equal to 0. So by using the node equation, we have written this equation, and after solving this, we will get the value of Vc, that is 23.33 volts. So this is the value of Vc. We have find the value of this Vc, right? So this voltage will be the voltage at point A, as there is no current between node C and node A. So whatever the voltage we have found at this node, this voltage is also across this A and B. Why is it so? Because no current is flowing through this resistance. Why no current is flowing through this resistance? Because current will only flow if the circuit is closed, and here you can see the circuit is not closed. So current will not flow through this 5 ohm. So whatever the voltage is at this node, the same voltage will be reflected at this terminal A and B. So the VTH value is equal to this Vc, which is equal to 23.33 volt. So we have found the VTH also. Now the next step 3, the next step is 3, we have to find the Thevenin resistance. So how will we find the Thevenin resistance? So to find the Thevenin resistance, what we will do, we will replace these sources by their internal resistance, right? So in this circuit you can see that we have one voltage source and one current source. So in previous slide I have already told you that the voltage source, you will remove this voltage source and you will short circuit it, and when the current source is there, you will open it, right? So after doing this, you can see the circuit would look like this. So here we can see the voltage source was there, so we have short circuited this path, and the current source we have opened this, right? So now from we will find the equivalent resistance from this terminal AB, from the point where we have removed the load resistance. From there we will find the R equivalent, like we will look from here. So looking from here, what does it mean? Looking from here means the current is coming from here and it is getting divided into 5 and 10. It means if current divides, it means these two branches are in parallel. So these two branches are in parallel, right? So you will look from this side, but you will solve from this side. Solve from this side means you will solve from this side means this 5 and 10, they are in parallel. So 5 and 10 are in parallel, and this combination will be in series with this 5. So this combination in series with 5, when you will solve, you will get 8.33 ohm, and this is nothing but the RTH, right? So this is the value of RTH. So we have completed this step 3. Now the last step is to you have to replace the network with the Thevenin voltage source in series with the Thevenin resistance, and the resistance in which the current is to be obtained, if there is any resistance, right? So the circuit which was given, now we have replaced that circuit with the Thevenin equivalent circuit. So the VTH value we have already find, that is 23.33 volt, and this is the RTH value and this is the VTH value, right? So this is the Thevenin equivalent, and the question was we have to find the current through this 3 ohm resistance. So we have connected this resistance at terminal A and B, and now but just by looking at this circuit you can find the value of I, which is passing through this R resistance. So I will be equal to 2.06, and this is our required answer. This is the required answer, right? Now next is example 2. Using Thevenin's theorem, find the current in 1 ohm resistor in the circuit, which is shown in figure below. So this is, I have taken this question I have taken from the previous year question paper, that is from 2021-22 question paper. This question has come. So now the question is, you have to find current in this 1 ohm resistance, right? So what is the first step? The first step is that you will remove this resistance and you will mark the terminal, whatever you want, A, B, X, Y, whatever you want to name it, you can name it, right? So you will first remove this resistance. So in here you can see that we have removed the resistance, and now the second step is we have to find the voltage. Like after removing this, we have to find the Thevenin voltage across this terminal. So how will you find the Thevenin voltage? So this is terminal A and this is terminal B, right? So this is terminal A and this is terminal B. So if you will the voltage across this 2 ohm, and if you will consider this 4 volt, so whatever is the voltage, if you consider all these voltage, you will get the voltage across this terminal A and B. So for finding that, you should know the value of current which is flowing through 2 ohm. So how will you find? So if you see, I have marked the current I1 and current I2 here. So I have chosen here the current, this is the loop current I1, and here I have chosen the loop current I2. So here if you see, in this loop there is one current source, 1 ampere. It means this I1 value is equal to 1 ampere, right? And I2 value will be 3 ampere. Why I have put minus here? Because the direction which I have taken is opposite to the direction of current which is flowing through this loop. So if you consider this source, the direction of current is anti-clockwise, right? The direction which I have taken is clockwise. You can also take anti-clockwise, but according to direction I have written it minus 3a. If you take it as anti-clockwise, you can write I2 is equal to 3 ampere. Now, what will be the current? You know, the current flowing through this loop is I1, which is equal to 1 ampere, and I2 is equal to minus 3 ampere according to this clockwise direction, but the actual direction means anti-clockwise. So if you see, this I1 is direction in 2 ohm is toward this side, and if you see, the direction of I2 is also same. So it means the I1 value is 1 ampere, I2 value is 3 ampere. So the total current which is flowing through this 2 ohm will be equal to 4 ampere, right? So now we know the current flowing through this 2 ohm. So I have drawn this path from A to B here. So if you will go from A to B, you can see if you start from A, here from A, so current is flowing through this direction. So this terminal will be positive, from higher to lower side will flow. So this will be positive and this will be negative. So here first you will reach the positive, then negative, and then if you come here, the here you will get the positive terminal first, then the negative. So again you will get here the positive terminal, and then you are getting the negative terminal, right? So now you know the current which is flowing through this 2 ohm resistance is equal to 4 ampere. So the voltage will be 8 volt, and here we know the voltages, as this is a voltage source, this is a 4 volt, and the polarity is plus minus, and here also polarity is plus minus. So this 8 volt and 4 volt, what will they will get added? So here the value of VAB means voltage across this AB terminal, or we can also say VTH. So this will be equal to 12 volt. So this is the 12 volt is the value of VTH. So we have find out the value of VTH. Now next we will find the value of RTH. So to find the value of RTH, first we will if there is any voltage source, we will short circuit it, and if there is any current source, we will open it. So here we have a current source, so this portion is open, here also it is open, here we have a voltage source, so here we have shorted it. And now if you see, we have to see the equivalent resistance through this terminal A and B. If you see, through this terminal A and B, only 2 ohm resistance is there, right? So R equivalent is equal to 2 ohm. So RTH value is equal to 2 ohm. So after this you will draw the Thevenin's equivalent circuit. So here VTH value is 12 volt, RTH is 2 ohm. Now we have connected the RL, which value is 1 ohm. So after this we have calculated the value of IL by putting the value of VTH, that is 12, RTH 2, RL 1, we will get 4 ampere, and the current direction will be downward. So current direction will be downward. So that's why I have shown the arrow here downward, means it will be flowing like this. The next example, using Thevenin's theorem, determine the current through 6 ohm resistance. 6 ohm resistance means this is a 6 ohm resistance. So again, this is a question from previous year question paper, that is from 2020-21. So similarly, first we will calculate the VTH. So for calculating VTH, this resistance, we will remove this resistance, right? It means we will open this terminal. So A and B is now open. So voltage considered through this path, if you consider all the voltage through this path, this will be equal to the VTH, right? So to know all the voltage here, we know it is 4 volt. What will the voltage across this 2 ohm? The current value is required here. Again, what will be the voltage across this 4 ohm? Again, you need a current value here. Then here we have a 4 volt. So if you see this 2 ohm, no current will flow. Why no current will flow? Because this terminal is open, right? It means there will be a 0 volt. Now, to find the value of current in this 4 ohm, we will write a loop equation here, right? So loop equation you will write, if I am considering the current flowing in this loop is I1, so here you can write minus 4 I1. Then again here, if you will go here plus minus, and if you are considering the polarity here, so you are going from plus to minus, means negative. So minus 4 I1. Then this is 5 volt, you are going from minus to plus, so you will write plus 5, and here again you are going from minus to plus, so you will write 3 is equal to 0, right, according to KVL. So writing this equation and solving this, you will get the I1 value is equal to 1 ampere. Now we know the current flowing this 4 ohm is equal, the current flowing through this 4 ohm is 1 ampere, right? So now we will draw this path from A to B. So I have drawn this path from A to B. So first you will see, you will get this negative terminal of this 4 volt. So negative terminal, then you will draw the positive terminal because we are going from A to B. Then you will draw this 2 ohm resistance, then you will draw this 4 ohm resistance, so 2 ohm, 4 ohm, and then you will draw this 5 volt. So when you are traveling from A to B, first you will reach the negative terminal. So here you will draw the negative terminal first, then you will draw the positive terminal, and then you are reaching the terminal B, right? So now we will see all the voltages here. So here we have 4 volt, here we have 0 volt because no current is flowing through this 2 ohm resistance. Then here 4 volt because the current flowing through this 4 ohm is 1 ampere. So 4 volt and the 5 volt, this is the voltage source, right? Now we will see the polarity, this is minus plus, this is plus minus. So this will cancel out, only you will get 5 volt, right? 5 volt, but the A terminal will be negative and B terminal will be positive. So if you are writing VAB, this is equal to minus 5 volt. A will be negative with respect to terminal B. So we have find the value of VTH. Now the next step is to find the value of RTH. So to find the RTH, what we will do, if there is a voltage source, we will short it. If there is a current source, we will open it. So if we see in this circuit, we have only these voltage source, right? So we will short this. So circuit will look like this. So you will see R equivalent from terminal A and B, but you will start solving from this side, right? You will start solving from this side. So if you see this 4 and 4, they are in parallel. So this parallel combination will be in series with this 2. So that's why I have written 4 in parallel combination with 4, which is in series with 2, which is equal to 4 ohm. Right? So this is equal to 4 ohm. So now we know the value of VTH, that is 5 volt, and this is terminal A and this is terminal B. As we are writing terminal A, we know that A is negative with respect to B. So here this is a very important thing. So you will put minus sign here and you will put plus sign here, right? So when you are making the Thevenin equivalent Thevenin equivalent circuit, here you have to see that this will be the negative and this will be the positive. So after making this circuit, you will find the value of IL, and this will be coming 0.5 ampere. After putting the value of VTH, RTH and RL, the value of IL will be 0.5 ampere and the direction will be upward. It means the current is not flowing in clockwise direction, it is flowing in anti-clockwise direction, right? from circuit also you can see the current will flow from positive to negative. So current is flowing anti-clockwise. So in this resistance 6 ohm, it will be upward, right? So we have find the value of VTH, we have find the value of RTH, then we have make the equivalent circuit, and we have find out the current which is flowing through 6 ohm resistance, and this is the required answer, right? Now we will take one more question, which this question came in 2018 and 19. So determine the current through 2 ohm resistor using Thevenin's theorem, right? So now you have to find the current in this 2 ohm resistor. So you will, what you will do, you will open this this load resistor, right? So I have opened this load resistor, so I have marked A and B here, and what you can do, this 3 and 5, you can see this 3 and 5, they are in series, right? So if you will add this the 8 ohm, this will become 8 ohm, and if you will solve this, this resistance will come like this, and the value will be 8 ohm, right? Will be 8 ohm. So this you have combined this. So now you can see, you can do the source transformation. Source transformation, this is 6 ampere and this is 8 ohm resistance. So if you do the source transformation, how you will do, to find the value of voltage source, what you will do, 6 into 8, right? So find the value of voltage, it will be 6 into 8, so 48 volt, and this 8 ohm will come in series with this 48 volt source. So I hope you know the source transformation. If you don't know, you will just multiply these two values. The I, basically this is I and this is R, so I into R is will give the value of V, that is nothing but the value of voltage source, and this resistance now will come in series with this voltage source. So now this circuit has become very simple. So now just you will find the value of current which is flowing through this loop. So you will find the value of I. So you know this is a voltage source 48 volt and 15 volt. So 48 minus 15 divide by this 4 and 8, that is 12. So 48 minus 15 by 12, you will get the value 2.75 ampere, right? Now to find the value of VTS, that is from A to B. So VAB is equal to VTS. So again I have drawn this path from A to B. So here you can see the 4 ohm resistance is here. I have taken this path. You can take this 8 ohm and 48 volt also. There is no problem. So I have taken this path 4 ohm and 15 volt. So 4 ohm and the 15 volt. So current flowing through this 4 ohm is 2.75. So voltage will be 11 volt. So 11 volt and 15 volt. So they are in plus minus and plus minus. So both the voltage will get added. So 11 plus 15, this is 26 volt, right? So you will get 26 volt. The next is RTH. You will find the value of RTH. So if you see this circuit, right? See this circuit, I have redrawn this circuit, and I have removed these voltage sources. So you can see this is terminal A and this is terminal B. Here we have 4 ohm and here we have 8 ohm, and you can see that clearly see that these 4 and 8 ohm, these two resistance are in parallel. So if you solve this, you will get 2.66 ohm, and then after you know the value of VTH, you know the value of RTH, then you can draw the equivalent circuit, that is VTH and RTH, and now you can here this is the load resistance. So RTH value is 2.66 and VTH value is 26 volt, right? And RL value here is 2 ohm. So what will be the value of IL? So you can find the value of IL by VTH upon RTH plus RL. So you will get 5.579 ampere, and this is the required answer. So I hope now you know, by this time you know how to solve the equations related to the Thevenin's theorem. So these are the applications of Thevenin's theorem. It is very useful for analyzing power system and other circuits where one particular load resistor in the circuit, and recalculation of circuit is essential with each trial value of load resistance to find voltage across it and current through it, right? And in the source modeling and resistance measurement by using the Wheatstone bridge provide application for Thevenin's theorem. It has some limitations also. So, Thevenin's theorem first limitation is it is not applicable to the circuit consisting of non-linear elements. So, if there are non-linear elements, you cannot apply the Thevenin's theorem. So, this circuit, the statements, in a statement itself, it is written any linear two-terminal network, right? So, it is not applicable for the non-linear elements. Then second is it is not applicable for unilateral network. It is not applicable for unilateral network. Like if there is elements like diode is there, or we can say semiconductor elements are there. So, you cannot apply the Thevenin's theorem there. Then there should not be magnetic coupling between the load and circuit to be replaced by Thevenin's theorem, right? There should not be any magnetic coupling where it should not be there between the load and the circuit. In load and circuit, there should not be any magnetic coupling. So, if there is any magnetic coupling, you cannot apply the Thevenin's theorem. Then in the load side, there should not be controlled sources or we can say a dependent sources controlled from some other part of the circuit, right? So, at load side, there should not be any controlled sources. You cannot apply the Thevenin theorem in such kind of circuits. So, these are the limitations of Thevenin's theorem, in which circuit you can't apply it. Now, next coming to the Norton's theorem. So, Norton's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of current source here, right? Current source in parallel with resistance Rn. Like in Thevenin also we are replacing the two-terminal network with an equivalent circuit, but in Thevenin we are replacing it with a single voltage source and a resistance in parallel with it. But here we are replacing the it is replaced by equivalent circuit which is consisting current source which we denote as IN, or we can say Norton current. We also called it as a short circuit current also, and in parallel with resistance Rn, that is Norton Rn. So, where this IN is the short circuit current through the terminal and Rn is the input or equivalent resistance at the terminal when the independent sources are turned off. So, here this is the circuit. We have replaced this circuit with the Norton equivalent circuit. So, in Thevenin we have drawn one voltage source and we have connected the resistance in series with it, but here the current source is here and now this Rn is connected in parallel with this. So, this is the Norton equivalent circuit for any given circuit, right? Now, how to find Norton current and resistance? Like we have seen in Thevenin how to find VTH and RTH. In a similar way, how to find the current and resistance. So, to find the value of Rn, that is Norton resistance, is same as we have find the value of Thevenin resistance. The procedure is same, right? There is no difference. Only we are here we are finding the resistance in for the Norton's theorem. So, this Thevenin and Norton resistance, they are equal. Now, how to find IN? This is the short circuit current from terminal A to B. What we will do? We will remove the load here. Then we will short this path and we will find the current flowing through this short circuited path. So, this ISC is equal to the Norton current, right? So, ISC or Norton current, both are the similar thing. So, now if we see here the Norton equivalent and the Thevenin equivalent, right? If you know the Thevenin, if you have a Thevenin equivalent, you can find the Norton equivalent also by using the source transformation, and it is vice versa. If you have a Norton equivalent, you can convert it into the Thevenin equivalent also. But if the question comes that you have to convert this into the Norton equivalent circuit, so the procedure, the steps you have to follow for the Norton theorem only, right? So, what are the main steps? You have to mark the terminal and remove the resistance, if any, in which current or voltage across is to be obtained. Then the second step is find the short circuit current between the terminal. Then you have to find the short circuit current between that terminal. Then third, you have to find the equivalent resistance. The similar way you have find in the Thevenin. Then fourth, replace the network with the Norton current source in parallel with the equivalent resistance and the resistance which current is to be obtained. So we'll take one question. So this is from 2018 and 19. So you need to find the current in 12 ohm resistance using Norton theorem for the given circuit. So 12 ohm, here we have a 12 ohm. So here we have a 12 ohm. So 12 ohm, what we will do? We will remove this resistance, and after removing this resistance, what we will do? We will short this path, right? So we will just short this path and we will find. So the current flowing through this is nothing but the Norton current. So we will write the here apply the nodal analysis. So suppose here V1 voltage is here, here V2 voltage is here. So after writing the equation, this is the equation 1, that is here V1 by 8 and V1 minus V2 by 5. So this will be equal to here, this is 20 ampere. So this 20, where this equation will come, this is first, and for writing equation for this node, that is V1 minus V2 by 5, then 40 plus V2 by 4, this will be equal to IN. So by looking at this circuit, we know that this V2 value is 0 because here we have shorted it. So we can easily find the value of Vn, and after putting the value of Vn, V2 in equation 2, you can find the value of IN, right? So you can find the value of IN, which is coming 290 by 13, and to find the Rn, the procedure is same as in the Thevenin. So we will draw the Norton's equivalent, and we will find the current in this 12 ohm by using current division rule. So basically the total current, that is IN is the total current here, 290 by 13, it is getting divided in Rn and RL. So you have to find the current in RL. So first you will write the Rn in branch where you don't have to find the current, then the total resistance. So it is coming 4.531 ampere. And this is the next question. You have to find the current in 6 ohm resistance by using Norton's theorem. So the 6 ohm, the same question has come for the Thevenin also. So you will just short it. You can see you will short it, apply the node analysis, write down the equation, you will find the value of VA. Then after finding the value of VA, you can find the value of IN, right? So VA minus 4 by 2, this is for the value of IN. This current which is flowing here is nothing but the IN. So this is minus 1.25 ampere. So and easily you can find the value of Rn, which is equal to 4 ohms, and after that you can draw the Norton's equivalent circuit and you can find the value of IN, right? Now the next question is, you have to find the current through terminal AB. Here they have specified the terminal, so you will short it, right? And if you will short it, you can see the 30 ampere will flow through this IN. The whole current will flow through it. So IN value will be 30 ampere, and for finding out the Rn, you can see this 3 and 1, they are in parallel, and this is in combination with 2 ohm, and no current will flow because it will get open, and this combination will be in parallel with 4. So that's why I have written 3 is in parallel with 1, and this combination will be in series with 2, and again this whole combination is in parallel with 4. So the Rn value is coming 1.63. So you can find the value, and these are the references which I have referred for this lecture. This is the book D.P. Kothari and I.J. Nagra. This is for basic electrical engineering, and I have referred the AKTU previous year's question papers. I hope you understood the Thevenin's and Norton's theorem well. Thank you.